Hello, hello, hello. Welcome. How are you all doing out there? It's time for another exciting installment of me attempting to do things with TypeScript and helpful people on the stream chat going, "That's not how you use TypeScript." And between my between my efforts and everyone else's advice and fairly cavalier attitude to learning from our own, you're learning from my failures, we are slowly and gradually putting together a interpreter for the Rockstar esoteric programming language built in TypeScript. And those of you who were on the stream the other day, we got about as far as that. We got the substantial, or the significant milestone of 84 failing tests. Now, that's not generally the kind of thing that you're sort of thinking, yes, we want 84 failing tests, but what I'm doing here is I am building something to implement an existing specification, and the great thing about test suites is that when you've got a good one, if you're trying to build a new version of the product or the tool or the library or whatever it was that you were working with, you can use the test suite to tell you whether it's working or not. You can use the test suite gives you a sort of calibration point. Have I broken this thing or does it work the same? And what we've got thus far, if I switch over into my VS Code workspace that we're working with here, we've got a interpreter. That thing can come out. We don't need that. That was commented out, but it's all right. We have revision control. What I did was to hack together an interpreter that will run my new Rockstar compiler or Rockstar interpreter, which is called Petrucci, after John Petrucci, who plays guitar for Dream Theater, because the old one was called Satriani, and John Petrucci kind of came after Joe Satriani and does a lot of the comparable kind of things, and is more technically ambitious. That's the joke that I'm sticking with. We have 2 passing tests, and that's right, we do. And those 2 passing tests are the 2 tests I'm about to delete. So what is going to happen is this project is kind of slowly going to converge. That existing test suite, I'm going to run it until kind of some of the heavy lifting starts to work. And today we're going to see some of those tests start passing. But then I'm going to start changing, because I want to change the language spec around a little bit, because there are some things, as those of you who've sort of seen me talk about it, yeah, it's all right. I'm going to switch in a second. Let's. There you go. You can see. There we go. Have a look at some code. Hey Martins. Yeah, lots of people prefer Satriani, but the point of picking them both is the world is a better place for having both of them in it, and as it is with instrumental rock guitar players, so it is with Rockstar interpreters. So yes, I'm going to change some of the language features. There are going to be breaking changes. Petrucci is going to effectively be Rockstar 2.0. So where we got to last week, as I said, we had a bunch of tests, and when we run those tests are failing, most of them. The only ones that are passing are the fake ones, which are not actually representative of anything real. And the reason why they're failing is that our language grammar that we are working with at the moment is nonsense. It is this thing here, and this is nothing, not even remotely related to a Rockstar language syntax. This thing is a fake language that I built to demonstrate certain kinds of arithmetic expressions. So what we are going to be starting to do today is we're going to start kicking this thing around and get it running some actual Rockstar code. Now, I'm going to pick we should be able to, if we have a look in the IO folder here, we've got hello number, we've got hello world, we've got, so hello number and hello world, they should be pretty low-hanging fruit for what it is that we want to do. Now, the other thing that I'm doing here, if you look closely here, you'll see we've got a rock file and we've got a rock out file. And that's kind of high maintenance. That is a pattern that I don't like very much. So what we're going to do is I'm going to keep this thing in the background, but I'm not going to run this set of test fixtures every time I do anything with it. This is going to be something that we toggle in and out to do some kind of regression testing. Instead, I'm going to build up a new set of test fixtures as we go along. One, they're going to be kind of better structured around what it is that we're getting the language to do, and also they are going to use the new syntax that I've come up with, which allows us to use decorations inside the code like this to indicate what we are expecting to get printed to standard out by the results of these expressions, which makes the whole thing a little bit easier to kind of reason about when you're looking at the code and figuring stuff out with it. So let's get cracking. Let's do some rockstarring first. So I've got test fixtures. Now I'm going to kick things off by, I'm going to create a new folder in here called IO, because the first thing that we are going to start with is we are going to start with output. So let's just go with output dot numbers dot rock. So this should now Rockstar supports a bunch of different aliases for output, so what I'm going to do is I'm going to implement support for that thing there. So this is I'm going to have shout1, I'm going to have say2, I'm going to have whisper3, I'm going to have scream4, I'm going to have shout, because these things need to be case insensitive, 5, I'm going to have say6, I'm going to have whisper7, and I'm going to have scream8. And the new syntax that we got in here should be, so this is expecting 1. This is expecting 2. This thing is going to expect 3. This thing is going to expect 4. This thing we're expecting 5. This thing we are expecting 6. This thing we are expecting 7. This thing we are expecting 8. So we got a new test fixture, output numbers. Now, first thing I'm expecting to see is that the number of failing tests should go up. Okay, cool, 84 to 85. This is good. Now, I just want to take out that v1 text thing. There's a couple of ways that I can think of doing that. One of them would be just to move it. Pick up that chunk of code and stick it somewhere else so that the v1 folder is no longer part of our test fixture here. The other one, give me 1 second. I think I just did Nope. It's Amazon Christmas. I'm awaiting exciting cardboard packages from Uncle Amazon. So, shout, say, whisper, scream, that should all be good. Output numbers. So what I want to do now is, let me just get this v1 thing here and hack this out. So the easiest way to do that is probably, I'm just going to put a flag in the code. So here is example.test.ts. I'm going to rename this to be, no, don't delete it, rename it. This should be called fixtures.tests.ts. This is, of course, TypeScript, so we have type annotations here, and I got a jest interpreter plugged in here that can work with TypeScript without too many difficulties and that kind of thing. So what we got to do is, let's do path.string on there. I'm just going to put a test if path string equals v1, return. So that should ignore that v1 folder, and I should get 3 failing tests. 1 failed, 2 passed. All right. And the one that failed there is output.numbers.rock, and that is indeed failing. So example.rock and example2.rock, those are our simple ones. They can go. We don't need them. I'm going to drop them down over here, move them into v1 just as the easiest way of getting them out of the way. Just should give me a single failing test. All right. Actually, you know what? This is not even the simplest possible test case. The simplest possible Rockstar program is probably a blank file. But we're going to skip past that one for now because it's not very exciting. Okay, so what do we need to do to get this thing here working? So the backbone of it exists. We have the guts of an interpreter that can already handle input and output and those kinds of things. So output numbers.rock. I'm going to have a go over here. I'm going to have a look in the grammar. So we need shout, say, whisper, and scream. These are the language keywords that we need to support. So parser.peg. Now then, there is a thing that we're going to need to do, which I'm going to throw in here, even though kind of we don't need it yet. If you have a look at, let me open up the CD project, CD GitHub, CD Rockstar, the original one. If I do a code in here and have a look at the way the Satriani interpreter works, something that I never quite found a nice way of doing with expression grammars, with peg grammars, is a nice way of working out what things are keywords. What I had to do in here is that this is keyword function here. I basically, every time I define a keyword, I had to define it in 2 places. And define that, I don't like that. That kind of breaks the don't repeat yourself, you know? Because if it works in one place, that should be enough. You define it over there and you're done. So, and this is keyword thing is then used in a couple of places. It's the thing that lets you make sure, basically in Rockstar, you can use variables without declaring them as long as they're not keywords. And that that's the only place that's used, is in variable identifiers. I wonder if there's a nicer way around that. Anyway, we can skip over it for now. One of the interesting things you'll find about watching a stream like this is you see me change my mind all the time. I'll be like, I should do this, I shouldn't do that, maybe I'll do that, I won't do that, I might do that. And then later there'll be a thing where you go, oh yeah, that's that thing that you said you were going to do and then you didn't do, and then it came full circle and now you're doing it. So what we are going to do in here is I am going to define a state put in here, can be an output or it can be a return. That's fine. Well, actually, we are no longer supporting return statements. That can come out. We are not doing that anymore. That return can be... The question is, do I have enough code already implemented with my simple syntax engine that I want to keep it, or do I want to throw it away and start the whole thing all over again? Let's take a look at this and have a look. Let me just check one detail here. So, yep. Sorry, I just have a thing popped up that I need to check. The joys of twitching. I'm doing an online birthday party for my niece in a couple of hours, doing like a magic show over Zoom, which is, you know, a little bit ambitious by the standards of lockdown style entertainment, because the audience will be small children. Anyway, right, let's crack on. So we've got output expression, we've got a return expression. I'm probably gonna hack this whole lot out. We have revision control. We can get it back without too many difficulties. So we are going to, I want return node, addition node, multiplication node. All I want in this is number nodes and output nodes. So let's have a look at syntax.ts. Yeah, I like that, Sanal. That's sitting down with a problem and a general idea, back and forth, trying to assemble the things you know how to do. You learn as you go along. When you learn stuff, you're like, oh, I've learned a thing now, and because of what I learned, the thing that I thought was making sense doesn't make sense. That lot we can get rid of. Number node we're going to need, output node we're going to need, return node can come out. We'll hack that out of there. So we've got number nodes, output nodes, actions and results we probably need to keep in here, because those are going to be very useful for the stuff we're doing later. We've got an output expression, so a statement can be output equals, so I'm going to define a thing in here. I'm going to say in the grammar, all right, statement can be an output. An output is a say followed by some white space. So that is white space or comma. Now, this is the interesting thing. There are certain things where white space is optional and certain things... hey, Burnax691. That's Bernardo, isn't it? How you doing? So, welcome. So, yeah, we are mandatory versus optional white space. Now, this thing here, the underscore, that's kind of saying the white space is optional. And there are some language syntaxes where it makes sense for white space to be optional. Like if you think about JavaScript, you can do 4+2. But you probably can't do like... actually, JavaScript is a terrible example for this because all spaces in JavaScript are optional. Trying to think of an example. Yeah, you got like class foo versus class foo. One of them the space is mandatory, the other one the space is optional. So that in there, the space that could be between the plus is not required. So I need to say output. That needs to have at least one of the preceding expression, and then I need to define say in here can be. It can be say, or it can be shout, insensitive, or it can be whisper, insensitive, or it can be scream, insensitive. So that plugs in there, that plugs in there. That should give us that syntax can come out. What's the comment syntax in PEG? Is it just // Let's see if that works. An output here, as I say, is an expression. I'm going to chop out all this binary stuff at the moment. So all of that can come out. Hash in a PEG file. Well, let me check the documentation. So we are PEG.js common syntax is what I'm looking for. 2 + 2 + quotes 2 - 2 is 40, says the JS compiler. PEG.js documentation, that's what we want. Grammar, syntax, and semantics. Not line-oriented, ignores white space. You can use JavaScript-style comments, //. All right, so thank you, Visual Studio Code, for doing exactly the wrong thing there. There's got to be a way of fixing that. You know what? This whole chunk can come out just like so expression equals number. That can come down here. So everything out to the end of the file is now noise. We are ignoring that. The syntax highlighting on the PEG file here is completely whack. It's I don't know what. Yeah, it's found it. VS has picked up that it's a PEG grammar file, but I have no idea why it thinks that. Peg.js. There we go. Look at that. Ah, beautiful. Absolutely beautiful. And fixed and nice and clean and right. So let's have a look at what do we got? So there was that, there's that, there's that, there's that. Yep, that's okay. So we've built a syntax here where a program is a bunch of statements. A statement is an output. An output is the say or any of the supported keyword aliases, followed by an expression. Expression has to be a number. Number has to be a string of digits. We got white spaces. Comments are valid because we are going to be able to do, say, woo, 4. And that will actually work. Should it work? I don't know. Let's put a test in for it. There we go. And okay, so now I got to run the whole thing through the build pipeline for this, which is npm run build, because we got a slightly complicated relationship between cannot find. I'm in the wrong folder. Of course, I'm in the wrong folder. I need to be in that folder. We have a slightly complicated set of dependencies where JavaScript, TypeScript gets compiled into JavaScript, which gets imported by PEG, which gets compiled to JavaScript. Boom. All right. This is nice. Line 749 expected. That's trying to compile interpreter.ts, and it's choking. Why is it choking? 749 expected that, but that found line. Okay, where's that error actually coming from? Probably syntax. Let's try CSC syntax minus minus strict syntax.ts. That works. All right. Peg.js parser.peg. That's the thing. Yeah, line 749, so it's our grammar is wrong. So line 749. Of course. That does not take... There. Possible infinite loop. Line 9, character 14. Output equals say plus node expression. Yeah. Yeah. Curious. That should definitely consume something. He says running it again on the distant off chance that'll make any difference to what's going on. But no. So output equals say. That should consume say and the node. It should always do that. Statement equals output. Output equals that pattern should be fine. And that should consume that. Expressions are numbers. Node is an expression. Return new syntax output node. Maybe it's that thing there. Okay, that's weird. Why is it giving me that option? So if I add one, if I say it's got to have at least one of those, that gives me an infinite loop. If I say that, it doesn't, which is a little strange. Okay, that works. Maybe it's a problem with qualifiers on this thing. So if I'm out, let's run with that for a moment. Let me just check how the Satriani syntax did it. What did this thing do for its end of that? There's a math. Let's find white space equals tabs. That equals, yeah, that's a plus in there. Hang on. I think I remember what's going on here. I think the actual rule that we need to be looking at here is that the underscore here is that thing is a plus, and if that thing is there is optional white space between operators, we do that with it. Let me check how that thing runs through. So peg.js, but yeah. So if the white space is mandatory, white space has to be white space. White space can't be empty, but the mandatory white space can be optional if you understand the distinction. So output equals, say, a node expression, return one of those. Expression equals a number. Number equals digits. Run that. So now if I run the whole npm run test, that should build the TypeScript, build the peg, build the other TypeScript, build the JavaScript, run the Jest suite against it, and we should get something. Cool. And that broke. And why did it break? It broke because bracket found, because our grammar, our language grammar, is still supporting arithmetic expressions which do not exist in Rockstar. Comment is a round bracket followed by any number of things that are not a round bracket followed by another round bracket. That is the comment syntax here. So let's crunch that thing through, and our test runner that we built is also the thing that identifies the expectations. That needs to be looking for literal round brackets as well. There we go. And that needs to be a literal. And that needs to be a literal one of those. That needs to be a literal one of those. Right, let's see what we can see. So hit that one. Okay. Expected. Bracket, say, scream, shout, whisper, or T, but end of input found. Curious. So what that probably means is that it has found something it does not know how to work with. So I'm going to show you a little, we're going to jump into an online tool at this point, which I find very, very useful for doing this kind of stuff, which is on the Peg.js website. There is an online interpreter thing. So what I can do is I can jump over here. I can go into my Petrucci project. I can dig out my peg, grab that lot, drop that lot in here. That is probably requires not defined. Okay, this will be interesting. Actually, this should be okay. This should be able to give me the parse tree. And now I want my output numbers.rock. So grab that, drop that in here. I've just found a problem. I've just found a thing that is going to be a massive pain in the ass for this entire project, which is that it is the Dragon's Apprentice. Hello, and Dean Sturgis, welcome. Welcome to the stream, friends. The Peg.js grammar interpreter thing that I've got on here, that doesn't know how to do anything with TypeScript. And so all of my kind of intermediate parsery things here, they're not going to work. And they're not going to work because they can't find anything. So if I drop a thing in at the top here which says var syntax equals output node equals function foo, and do some of that and that and that and that and invalid shorthand property initializer. Yeah, we've just hit what is going to be a potentially extremely problematic brick wall with the way this whole thing is going, which is, yeah, well, you say that. I actually did that already. Do you know what yak shaving is? Is when you had a thing you were going to do, but in order to do the thing, you need to do this other thing, and you can't do that thing because of this thing, and you can't do the other thing because this other thing needs to be done first, and you end up getting spectacularly off track. Okay, so the problem that we have just hit is this very, very useful Peg.js online tool does not work. And the reason it doesn't work is that it is down here where we output something. It is trying to output TypeScript. And this thing here ain't going to work because this is saying syntax is not defined. And if we define var syntax equals that, that is now going to say syntax.numberNode is not a constructor. So I could say equals function that, and I could do that, and syntax.outputNode is not a constructor. So by hacking in this, okay, so we've got as far as the point now where this thing is at least giving us the error that we thought about and blowing up because line 10, column 1, expected say, scream, shout, whisper, or /t, but end of input found. Line 9, column 28, if I take that one out, line 9, column 1, line 8, column 21. So let's just play around with this for a second. Okay, so that kind of works. But as you can tell from this, the output, the parse tree that we got on the bottom there, is of no use to anybody. And that is gonna be syntax.numberNode equals function return So we're getting back our head of expressions. So what do we need to do to be able to turn this into something usable? Because what we need to do next is going to be very, very problematic if we cannot render our parse trees successfully to the output. What about the EOL token? The EOL token should be... That's why it's not working. So, okay, so that explains the problem with that one. Line 4, column 1, expected that, and there's that one. Okay, so we now have a successful shout 1, shout 2, shout 3. The problem is that the parser is working, but we have no way of visualizing the syntax tree that is being output from that thing. So syntax.numberNode equals... How on earth are we going to get that thing to behave properly? So I know Dean was probably half joking when they said we need to write a new PegJS online tool. But I think maybe we need to write a new PegJS online tool. Which was not what I was planning to do on the stream today, but hey, it would appear to be the next significant thing that needs to be done to keep this project going. So what do we need to do to be able to do that? And parse a variable, that's fine. Let's... Do I fork it or do I build a new one? That of course is the question. That's always the question. Yeah, unfortunately, I think your joke might have been the answer to the problem that we're having here. So let me just see what we can do in terms of... So syntax.numberNode equals... will this thing parse? Syntax.numberNode equals class... what's the syntax in TypeScript for a constructor? Let's take a little look at our syntax. No, that's the Rockstar interpreter. That is Petrucci. We want syntax.ts. That has a constructor that takes a thing. So let's have constructor takes a thing, and this dot thing equals thing. Syntax.numberNode, and then if we have syntax.outputNode equals a class, and the syntax.that has a constructor equals thing, this dot thing equals thing. And we need one more of those. Okay, this is curious. So it's giving us some output we can see now. But it doesn't tell us a huge amount about what's going on. So let's have a look at how we built those syntax nodes into the class of the language. So all these things have a number node extends, value mode, extend that, node, language. They all inherit from language node. So the toString output on these things in that parse tree is... You see, the way Satriani worked, yeah, you probably could. Let's actually try that. That would be interesting. So I compiled syntax.ts, and syntax.ts compiles to syntax.js. So that's an interesting suggestion. Let's have a look at... That's the wrong project. Syntax. Let's have a look at syntax.js. I mean, that's sizable, but if we drop that lot in here and scrub the exports, we're poking around right now. This is very much kind of poking things with a stick and seeing what happens. Exports is not defined. That's all nonsense. That's all nonsense. That's all nonsense. Interesting. So that's now building a parser successfully, but then the parser is failing because it says exports is not defined. Which is weird. Where is exports defined in this thing? Do we actually have that anywhere? Exports action equals exports dot action function. Yeah. So this is doing some. All right, that's clearly the syntax that the TypeScript compiler uses to output enumerated types. And that's not going to work. And that's not going to work. And syntax is not defined. Okay, so no, it looks like... yeah, enums. I think what you did there, yeah, that might work. So let's hang on. Let me grab the... that whole chunk of JavaScript again. We're going to come back over here. We're going to scrub at the entire header block of the peg grammar file here. The logical next step, of course, is that we don't use peg, and we build a parser by hand, which is for certain values of logical. So in here, I want to say exports equals that. And then plug in a whole bunch of, so let exports equals that, or to do that. Syntax is not defined, and then at the bottom of here, we are going to say let syntax equal exports. All right, so that has given us kind of what we want. There's a lot of unnecessary noise in here. Because, I mean, what we can see here is, okay, so the sharp one, if we just look at the parse tree we get out of that, what we no longer really have here is the way Satriani worked is that the parser turns Rockstar into a JSON document, and then the interpreter actually runs the JSON document, or the interpreter reads that JSON document, and that gives us the kind of abstract syntax tree representation. With this thing, we don't really have that notion of the AST being something useful anymore, because by putting the implementation behavior into the nodes that form part of the language structure, it kind of makes it very, very difficult to tell what's syntax and what's not. As in, ooh, hang on, we need that back. Which is not a problem for actually building the interpreter, but it's a problem in terms of supporting the tooling, because it means effectively having to create a visualizer that will kind of replicate this. You put the grammar on one side, you put your program in the top, we'll run that through, we'll get this thing out the bottom, but then it's a separate chunk of tooling to build the visualizer, which is going to give out the parse tree. Now what I'm trying to decide here is, okay, how many steps back do we need to go before the route around what we're doing? We've hacked in a bunch of code here, and you know, by sort of hacking all this export stuff into the top of here, that gives us a working online implementation of the parser. We can put some code into that, we can get a parse tree out. The parse tree doesn't make a huge amount of sense. So is the logical thing to do to replicate this thing on something that'll give us the grammar, the input, and the parse tree as a bunch of separate tools, and then allow us to run that through? And, you know, I think maybe it does. I think that might be an interesting little diversion to go on, is how do we take where's my syntax thing gone? So we've got our parsing expression grammar. Const syntax equals require syntax.js. Does require work in browsers? is very much a question on my mind. Let's have a look. If not, we need to run it through Browserify, which is going to add another layer of abstraction. So it does require work in browsers. If we can do that. Nodes that require for in-browser. No. Blocking call. CommonJS. That's not right. Browserify.org. I had a feeling Browserify was going to come up before very long. Whew. So. Okay, yeah, node module spaghetti incoming. I'm going to take a diversion here for a second, because there is a library somewhere. Write a parser with JavaScript, parsing by hand, simple compiler. There's peg.js. No. Where is... So this is something that came up when we were doing a bunch of stuff for Advent of Code about building, parsing expressions and stuff. ELE parsers are a type of parser we don't want. Where is the build a Lisp parser in JavaScript? I had somewhere, maybe Lisperator. There's definitely something out there that I've seen. Yeah, there we go. Lisperator.net, Mihai Bazon. PL tutorial, how to implement a programming language in JavaScript. So when I first started playing around with the whole idea of building a Rockstar interpreter thing, one of the things I looked at was this, which is a whole course about building a parser by hand in JavaScript. I'm going to do a quick refresh and have a look over this and see what it spits out. Just in case it turns out, because at the moment Peg has just given us, it does some very, very cool stuff, but it causes a huge amount of problems when it comes to trying to interoperate with TypeScript, as we've seen in various ways. So what are we going to learn? How to write a parser, how to write an interpreter, continuations, writing a compiler. Yeah, let's dream up a programming language. Boom, yeah, fine, whatever. It's got lambdas, that's nice. Yeah. Hello world, that's all fine. So, okay, let's write a parser for this language. So, writing a parser is moderately complex. In essence, it must transform a piece of code into an abstract syntax tree, which is a structured in-memory representation of the program. It's abstract in the sense that it does not care exactly what characters is the source code made of. Yep. So you can see this is the kind of thing that we're, I'm interested in being able to do, is translating Rockstar into something like this that I can then feed through an interpreter. Okay, so let's have a look at 3 parts. The character input stream. Stream object, peak, returns the next value. Next returns the next value, also discards it from the stream. EF returns true, and croak dies. Yep. So, that's relatively simple. There's the tokenizer. Returns a... Okay. So this is basically, consuming a stream of input, and first thing just looks at what's the next character on the stream, breaks it down into characters, reads each one of those. This thing will take that stream of characters and it will turn that into chunks that actually we can then use to build the abstract syntax tree for the language. So that's, yeah. So each of these functions then runs through and retrieves the whole. Nah, I'm looking at this. Yep. If that's a hash, skip the comment, read next. That just loops, read next, read next, read next. Okay. It's a dispatcher function. So dispatcher function is something that basically looks at something and goes, right, you deal with this bit. Next, you deal with this bit. Next, you deal with this bit. Goes round and round like that. Another thing is to notice if we don't consume, each time the parser calls for a token, we read one token in the case of an error. Yep. 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 So this it's a radically different approach to anything that I've worked with thus far. Let's have a look at the AST description. Numbers, strings, bools, lambdas, calls. Yeah, that's all pretty cool. That makes sense. Then we want to write a parser. So the parser here, the tokenizer, breaks things down into a stream of tokens. Yeah. Right. So, where are we at? Because there's a bunch of things we can potentially do from here. One of them is to try and get the Peg.js. Actually, let me have a look at one more thing. Something else came up in my research for this, which was a Peg.js TypeScript plugin. Plugin for Peg.js to generate TypeScript parsers. Now, I haven't had a look at this yet. So that should return the source code of the parser, return it from the CLI, return it in code. Yep. Let's have a look, see if there's some example code in here. Okay. Let's have a look. Arithmetics.peg.js. Yeah, that's... See, what I don't see in any of these examples is any indication of them actually using TypeScript as a kind of input, as something that the parser is relying on in the way that it works. This has got a bunch of functions in it, and then that's just return program. So there's no kind of strong typing going on. So what I'm wondering is, let me write some of these things down just to give us some. So, options 1. Rebuild the whole thing. One would be pure JavaScript abstract syntax tree. that takes out the dependency on TypeScript. It means that the online tool potentially works with it. 2 is build a visualizer for I don't want to rewrite it in Haskell because you can't run Haskell in a web browser, and the whole point is whatever comes out the end of this thing has to be able to run in a web browser, because if people have to install Haskell to become a Rockstar programmer, they're not going to become Rockstar programmers. It has to be one click. What is GHCJS other than a string of consonants in desperate need of a vowel? GHCJS, let's have a look at that. The Haskell to JavaScript compiler. Do I really want to click this link? Is this what we're going to do today? Haskell to JavaScript compiler. So there's only one small problem. I've never ever worked with Haskell. I don't know it at all. I know less than nothing about doing any kind of work with Haskell. So what is a pure JavaScript AST? 2 is a build visualizer for TypeScript ASTs. So that would be getting the peg grammar thing, plugging that in, trying to get something in a web page that will let us have the grammar in one window, the program in another, and visualize the abstract syntax tree in another one. 3 is investigate the peg.js thing. 4 would be find something else to do. 5 would be to do the whole thing with no visualizer. Okay, that one's kind of hard. I have no intention of trying to create a complete language runtime interpreter. Dragon's Apprentice says, I tried to write a language in Haskell for a jam, know nothing about programming languages or Haskell. It didn't go very well. I leave it to you, dear audience, to decide whether you think today's stream is going very well or not. We have hit what is a substantial brick wall. I am going to... What am I going to do? I'm going to... Okay, so I got about a half hour left on the stream today. What I am going to try and do with that is I'm going to poke around and see if I can get a local, kind of basically get to the point. You know, when we had the peg.js window open, which is here somewhere. I'm going to see if I can get to that point on something local that doesn't isn't kind of blowing up on all of the complexity and stuff we got here. So let's have a look at what I'm going to need to be able to do that. And I have a horrible feeling it's going to involve some unpleasant JavaScript-y type stuff. But let exports equals that, drop the whole lot in. So what I'm thinking... Just writing your own parser sounds like the proper thing to do. It kind of does, doesn't it? Like, it really, really does. Right, hang on. Let's have a look at this. Because what I'm thinking is this chunk of stuff here. It's filthy. I mean, it's horribly, disgustingly unpleasant, but it is probably possible to... Are we going to do this? Are we going to write a parser by hand? Is that really where this thing is going to end up going? Because the AST visualizer is still going to be a very, very useful thing. No, I don't think a parser would be terribly difficult. It's not something I've done before, but it would get rid of the expression grammar thing completely. My reservation about starting work on a parser from scratch is that you've got to wire in a lot of stuff to get to a point where you can kind of start round tripping it, and you can put things in and see them working and coming out the other side. But it might also be an interesting challenge. That sounds like something that could be a lot of fun. What the hell? Let's do some spiking on that. Let's see what we need to do. So first thing I'm gonna do is I'm gonna come over here, and I'm gonna do a get check at -b peg idea. Main reason why I prefer JSON is peg is the ability to have a custom lexer. Writing a lexer by hand is easy, but writing a parser by hand can be challenging when dealing with conflicts. Alright, so get add dot get commit -m shelving all the peg related stuff for now. Git push. Yes, that thing. Do that thing. Of course, that's what I want you to do. Why would I not want you to do that thing there? 6. JSON. There we go. So, JSON or handwritten parser. There we go. Those are options. So do something else instead. Nah, I want to do this. This is fun. Peg.js TS, maybe. Really not sure about that one. Build a visualizer. At some point, that is going to come up. Because it's one of the things that I would like to ship as part of this whole project, is a tool that people can type in their Rockstar program and they can see the abstract syntax tree that's coming out the other side of it. Pure.js AST, kind of, if we do that, we lose the nice kind of TypeScript turning the thing into language nodes that know how to evaluate themselves, unless we break the whole thing out. Because there is another approach here, which is where we parse the Rockstar into a JSON syntax tree using vanilla JavaScript and Peg.js. And then we have something that turns the JSON into the TypeScript that then evaluates itself. That's potentially another approach for wiring all these chunks together. I'm going to have a little look at JSON. Let's see what JSON does. JSON is Bison in JavaScript, but of course it is. So npm install JSON, get clone, yeah. JSON takes a file containing a grammar. Right, what I want. This is my. How does this thing work? I don't want the documentation. I want an example I can see of how this thing works. Basic.json. What is that? That's okay. That's not enough to help us. Basic2.json. Let me switch back to the code screen. There you go. So now you can see what I can see. Basic grammar that contains a nullable a non-terminal. Not useful. Calculator.json is that's okay. Yeah. Yes, this, like a lot of things, is jumping out as... I mean, there's a learning curve. I've not done anything with... because JSON is Bison, and Bison is like Yak, and Yak is yet another compiler, if I know my history. So, and I used Yak at university about 20,000 years ago. But I've not done anything with it since, which makes all of this just a little bit... interesting. All right, what I'm going to do today So there's two things. There's what are we going to do with the sort of final 20, 25 minutes that were on the stream today? And then what am I going to do about building a Petrucci Rockstar interpreter? TypeScript is currently causing... Hello, Chris. So we've just hit an interesting brick wall with the way this whole thing was going, which is there is an incredibly useful online tool on as part of the Peg.js package, which lets you visualize your syntax, and we have determined that that doesn't support the require syntax that's being used to build the peg grammars. But I think I can possibly fake it with something. What I am genuinely wondering is if it is possible in a relatively short space of time to implement just enough require support in JavaScript as a preprocessor directive for the peg grammar, such that the thing that's output does what we need it to do. So I'm gonna take a look and I'm gonna see if that's something that will work with this. So what do we got here? We've got a You have one of those days where there are too many kind of things not going according to plan for the number of brain cells that are currently pointing in the correct direction. Today is very much turning out to be one of those days. Right, let's have a look. I just want to do a quick right-click, inspect, see how this thing's put together. Because I think we should be able to crib most of it. There's the head. That is a code mirror is just the thing they're using for their syntax highlighting. Grab a bunch of CSS, which is not a huge problem. js/online.js. jQuery, there's the peg.js. There's the... So one of the drawbacks of doing any kind of programming on a live stream is the important part of the development process where you put the computer away and you go for a walk. It doesn't work. We have definitely hit the point now where if I was doing something like this for real, I would be like, yeah, this is not a problem that I think is going to get solved by looking at information on computer screens. Basically, because there's like a whole bunch of things we could do next. And the first step in all of them is something that does not jump out and strike me as the best thing to be doing. Round in circles. Let's have another look at the peg.js thing. Yeah. Well, actually, the next step would be talking about someone randomly, and then following on from that, peg.js TypeScript. This looked like a bit of a non-starter. At 5 o'clock, I have to do a live-streamed magic show for my niece's birthday party, which is going to be a challenge, absolute, pushing to the limit all of my capabilities to do with green screens and special visual effects and video and PowerPoints and all those kinds of things. Let's have a look at what we got. Like TypeScript Lamb, you'll love TS Peg.js, a TypeScript code generation. Yep. Right. We've got about 20 minutes left. I'm going to use 20 minutes to hack something that might not work. and I'm going to, what am I going to do? I'm going to wget this whole folder, start hacking it around to see if I can, actually, is it on GitHub? Let's have a look. Development, source code, docs. Please let that be the, no, that's the docs, there's the website. Pages, online.js. Yep, this directory contains the peg.js. Yep, yeah, that will build a static site. Export.js. All right, I'm going to git clone that whole thing, and I'm going to see if I can get a copy of that. Boom, grab that lot. Git clone that thing. Boom, there we go. So it's a point like this where I really hope that they have been completely honest about keeping their continuous employment or continuous deployment stuff all baked in and up to date and everything. CD peg.js, let's have a look at that. CD website, have a look at that. Node export.js, module not found, npm install. Actually, let me just do an npm install in the root in case there's anything else in here we're going to need. Legacy versions of mk derp. Make derp? Alright. Who is it who sell Node.js package spaghetti hell incoming? Node module spaghetti incoming, said the Dragon's Apprentice. Node module spaghetti incoming, but it's somebody else's spaghetti, so that's alright. CD website, node export. Actually, let's see what export.js does first. Yeah, node export.js. Module not found. Module not found. Cannot find module. Peg.js bundler target. Okay. Website. We got some prime yak shaving going on today, friends. Cannot find module peg.js bundler target. Why not? Because we don't have any bundling things installed. Because no, because bundle isn't even a npm thing. Bundle is a Ruby thing you can install via npm. That's going to make life interesting. There is no gem file in here. This is all fine. CD website. Okay, let's fire this up in code and see what we can see. And we've got templates, we've got pages, we've got development, installation. What am I looking for here? Online.js. Template equals required templates / editor.html. Yep, that's your grammar, that's your text area. Okay, that does indeed appear to be the bits that they've used to build that website thing. HTML. I love this kind of stuff. It's like, no, don't put the HTML inside the JavaScript. I think the ship may have sailed on that one as far as the internet is concerned, but, you know. Right. Okay, so that does look like the right thing. It does look like it is close enough to what we're doing. I'm going to punch that error message that we got out of that into cannot find module bundler target. Boom, grab that, copy that. We're mixing 3 languages, 2 package managers. God knows what the scripting is doing. Exactly right. But hey, it's all JavaScript, so it must be full stack development, right? Cannot find module bundler / target is what we're looking for. Cannot find module. Let's quote that so it's literal and required. JSX is all about putting HTML into JavaScript. Yeah, JSX is a... So I want you all to imagine for a second that it's not putting HTML into JavaScript, it's putting XML directly into Visual Basic. VB.NET XML literals, because that's a thing that happens. And in Visual Basic, in VB.NET, you can write code that looks like this. You can embed XML directly inside your Visual Basic source code, and it works. And you actually get like schema validation and compile time checking. And of course, when the internet found out that you could put XML inside Visual Basic, they got very upset because they thought this is the worst idea anyone had ever had. But then they come along and go, yeah, but you can put HTML inside JavaScript, and everyone goes, yay! Yeah. People get very attached to their choice of development ecosystem, and it's often interesting how, you know, when you sort of challenge people's preconceptions about what can and can't be done, you get some surprisingly emotional reactions. All right, so that cannot find bundler target, cannot find module bundler target at export.utils.js. Where is export.utils.js? That is here. Const bundler target equals require at peg.js bundler target. Does anybody know what the at does in JavaScript require syntax? At JS require. No, none of that helps us. Maybe I need to build a bunch of stuff first. Maybe I need to compile peg.js before I can then build their website. Which, given the thing I'm trying to compile here is the website interface that exposes the interpreter that runs off the output of the project build process, it would seem sort of, you know, vaguely reasonable that that might be a thing we might need to do. But, yep, okay, let me try a thing here. The chat counter in Restream chat, by the way, today is horribly broken, and it says there are 0 people watching, but I know you're out there because I can see you talking. But it's always a little disconcerting. It's like, where did everyone go? No, they're still there. Okay, so let's go back to peg.js GitHub and run that through again. And what do we got? We've got the parser generator and... Yep. And what? And now what? And what do we do? Let's have a look at package.json. Maybe there's something useful in here that runs. Ah, interesting. Spec, build parser, build dist. Ah, build dist bundle and build website. That's expecting a bundle. All right, let's try. Where are we? I don't want to be in website. I want to file close that folder. Jump in over here, crash out of that, code in that folder there. But at this point, npm run bundle. Missing script bundle. Why? There's peg.js. Have a look in our package.json. Npm run build dist is the thing that runs bundle. Npm run build dist. See if that works. That didn't work. Why did that not work? Could not locate gem file. Interesting. What is this expecting bundle to do? is the question. Because my experience of bundle has always been that bundle was a Ruby thing. Where is that? That's... Nope, 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 nope. I'm just hacking at random now. npm run build dist to run the script. Yeah, let's try it. npm run build dist. We did that, and it says could not locate gem file. And the reason it's doing that is when I type bundle on this machine, it's trying to run that. It's trying to run bundler version 224, and I honestly have no idea whether the thing that I get when I type bundle on here is the same thing that they get when they type bundle on there. No, it should be. That should be fine. npm install. Pull back the whole lot. That should work. Yeah. Bundle 210. So let's have a look at npm bundle and see what this is. Nope. So there's a thing called bundle, which is on npm, and the package is moved here and is now called neutron, which builds Electron applications. So dependencies, types node, bundle, bundler, code cover, ESLint. What is that dependency referring to here? Let's try what Adam suggested. There is no start node module slash bin slash. That's interesting. That's I found out a new way of crashing a window. Also backslashes though, Adam, because I'm on Windows. So if I type // nothing is going to work. So cd pegjs node modules /bin /bundle. Let's have a look at that. Let's start node modules /bin. What do we got over here? So we got stuff, and the question is, what is in here? There is bundler, there is bundler.cmd, and there is bundler.ps1, which is the PowerShell. But there is no bundle. So whatever bundle is running, your guess is as good as mine. Now I'm guessing that the people who maintain Peg.js did not maintain it on Microsoft Windows. So actually there's one more thing we can try here, which is we can use a WSL, spin up an Ubuntu thing on this. Yeah, that's all fine. So cd/mount/d projects, cd github ls, cd pegjs, how was it? npm run build dist. Bad interpreter. Yep. I think, on careful reflection, I'm going to knock it on the head for today. And I'm going to think about it. I'm going to sleep on it. And I'm going to probably do a little bit of research and come up with an approach. Yeah. 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 All right. Yeah, so we have, to recap, everything was going beautifully. And then we hit a problem where got to the point of, let's see why this Rockstar grammar doesn't work, fed it into the Peg.js online interpreter thing, which lets you test and debug your grammars by putting a grammar file next to, where is it? It's this thing here. We got as far as going onto this thing here, putting in a little bit of Rockstar code there, pasting in the grammar here, and just to run through the steps so everyone can see the exact point at which everything stopped working. This line here does not work in web browsers, which means that this tool doesn't work, which means that the incredibly useful ability to evaluate your grammar against your program and visualize the syntax tree doesn't work out of the box. And at that point, we identified a whole bunch of potential things that we could do next, ranging from let's hack something together. So we kind of got it working with some help from the folks on the stream by effectively doing a manual import here, which you can actually do by, as I discovered today, you can actually do that by going var or let exports equals something, and then you just paste in whatever the required file was, and then you do const syntax equals exports. And so that thing there, so one idea that I had is, well, what if we could programmatically do that so that we get the syntax.js injected in, yeah, the bundle thing. I think the bundle thing is a red herring. It's not interesting, and it's not directly related to what it was that I was trying to do. I have got the thingy Peg.js Online, this tool here, working locally before just by kind of w-getting and grabbing all the bits. I was thinking it might be a little nicer to try and do it based on a fork of their system, but getting that to build, out of scope of what I was trying to do today. So anyway, yeah, we got to this point. This thing doesn't work because it's doing a require. The require is necessary so that our parser can return bits of TypeScript. And so, oh, it has bundle inside. Let's have a look. Last thing I'm going to try. Thank you, Adam, for the comment there. So what do we got? We've got, if I open up this thing here, tools, bundler, bundler.js, package.json, target, Babel config, Peg.js tools bundler. Yeah, I am. Nah, this isn't really instilling me with a. Okay. So that thing bundle runs bundler.js. So, yeah, package.json. I'm looking at it now. All right. Anyway, so we hit a brick wall, and we spent entertaining 45 minutes or so looking for various ways around the brick wall. And we found a couple that definitely, if you put the hours in and worked with them, would yield some kind of results. I'm going to take this away. I'm going to take it away, and I'm going to give it some consideration, and I'm going to think about it, come up with an approach. There's lots of things we could potentially do next. I'm going to pick one that I'm going to do. Thank you very much for streaming in, tuning in, folks. Let's have a look. So the folks over here who are watching on Twitch, we are going to find a channel to raid, because I think I just saw that the Visual Studio folks are online. And they're a nice bunch of people, so let's go in and see if we can drop in and say hello to all of them. Yeah, Visual Studio is online. So Twitch people, we're going to raid Visual Studio. YouTube people, you're going to get a recommendation to go and watch a guy in Switzerland restoring a old tire pump that he found in a mountainside or something, which is cool because we love that. Thanks for tuning in, gang. I'll see you for the next installment when we will do something. There will be Rockstar 2.0 this year. The question is, does it still make sense to do it in TypeScript? So, take it easy, gang. See you soon.